Hello again. Greetings, everybody, and welcome back. I hope everybody's doing well. We're going to get into lesson 7. So for lesson 7, we're going to do question 10, okay? So we're going to use question 10 here as, so this is question 10, and it comes from Gauteng province. So this is 2024, and it's trial exam, so it's September. It's from Gauteng, and it's a paper from Gauteng. So we're going to use it as lessons for lesson 7. So, okay, let's get into the question. They say what? In an experiment, different light sources are shown onto the surface of an unknown metal. Okay. 10.1, explain the term work function. Explain the term work function. What is the work function for metal? Ten point one. The minimum amount of energy required to eject photoelectrons from a particular metal surface. From a particular metal surface. And 10.2, electrons with a maximum kinetic energy of 1.2 multiplied by 10 negative 19 joules are emitted from the surface of the metal when ultraviolet light with a frequency 6.3 multiplied by 10 14 is incident on it. Calculate the work function. Okay, so they gave us the frequency, and then they gave us the maximum kinetic energy. So we can come here and we say E equals to work function plus EK max. So then we can say HF equals to work function plus EK max. So they gave us the maximum. And then we can change the subject here. So then we can say HF minus, we can minus the EK max here, and then we get the work function. So then we can substitute. We can substitute 6.63 multiplied by 10, negative 34, and then multiplied by 1. 6.3, 10, 14. 6.3, 10, 14. Then 1.2, 10, negative 19. And so the work function becomes 2.98. So you use a calculator here. You get 2.98 multiplied by 10, negative 19 joules. So yes, that's what I get for the work function. Then for 10.3, what do they want? 10.3, 10.3. They say, will electromagnetic radiation with a frequency 3 multiplied by 10, 16 emit electrons from the surface of this metal? Choose from yes or no. Support the answer with suitable calculations. Okay, so the answer here is yes. So how can we know this? We're going to calculate the energy. Okay, so the energy, if the energy is greater than the work function, then it means that electrons will be emitted. Cool. So we're given the frequency, isn't it? 3 multiplied by 10, 16. So we're going to say HF, and then we're going to say 6.63, 10, negative 34, and then the frequency. We substitute the frequency here, which is 3 times 10, 16. 3 multiplied by 10, 16 equals to. And then we get the energy here. So you use a calculator here. It gives me 1.99 multiplied by 10, negative 17, and then joules. So as you can see here, the energy of this light is greater than the work function. So therefore, the energy is greater than the work function. So therefore, electrons will be ejected. Electrons will be ejected from this surface. That's what it means. Okay. Because the energy is bigger for this electrons and for this light. Well, electromagnetic radiation with a frequency of this. So the frequency of that, we calculated the energy, and we found that the energy is greater than the work function. So this means that it will overcome the work function. It will overcome the minimum amount of energy that is required to emit electrons, because that's what the work function is. And then 10.4, okay? 10.4, what does it say? 10.4, they say, when the photoelectric effect is demonstrated, a negatively charged plate is used. Explain why, when ultraviolet light is shown on a positively charged plate, no charge is lost by the plate. Okay, so this means that, okay, when a positively charged plate means that means there are very few electrons for the UV light to eject. So and so electrons are instead attracted to the plate. If the plate is positive, electrons are in state, okay? Are in state attracted to a plate because opposite charges, if they are opposite charges, attract. So that's why it means there are very few electrons. So the electrons will be attracted to the plate instead of away from the plate, because if it's positive, it means there is no excess of electrons. So it means that there are very few electrons that are available to eject from the plate. You understand? So that's why. Okay. Okay. So I hope that was helpful, and thank you for tuning in into lesson 7. Thanks for watching, and leave your comments in the questions leave your questions in the comment section, and then I will attend to as many questions as I can. Let me know what you don't understand. And goodbye for now. I hope to see you in lesson 8. Bye-bye.